My name is Chloe Cleppe, and this is my final lab for this semester in Chemistry 100. So throughout Chemistry 100, we have learned a variety of different topics while using different elements and compounds in order to balance equations. The chapter I'm going to be addressing today through an experiment showing copper oxidization while balancing chemical equations is chapter number 4. I will be focusing on the different parts of a chemical equation, how to balance an equation throughout, while showing you an experiment to go along with. This is an experiment that is kind of small, but it touches on a very larger aspect of Chemistry 100. So, pennies have a tendency to get dull over time because the copper in the pennies slowly reacts with air, forming copper oxide. Pure copper metal is bright and shiny, while oxide is dull and green looking, as you can see in this old penny. The goal of this experiment is to show the chemical reaction between Cu, copper, and oxygen, O2, which is their element symbol name. And over time, it will create copper oxide, which is CuO. And what happens when you react them in a bowl with sodium chloride, NaCl, and vinegar, CH3COOH, plus positive H2O. The experiment we will be dealing with today involves one small metallic bowl, white vinegar, salt, and also pennies. So let me explain to you really quick. So the pennies happen to be the product in the equation, and then we see that the salt and the vinegar are the reactants. So before we begin the experiment, we want to use our knowledge of balancing the chemical reaction happening between Cu and O2, forming copper oxide, CuO, the first reaction present. So the left-hand side of the equation would show the chemicals present before the chemical reaction, while the right side shows the chemicals present after the reaction. We begin with Cu plus O2 equals CuO, unbalanced. And you can go back and look at this in my paper as well for a visual. You do this by making sure that different atoms are the same on both sides of the equal sign. There is one copper atom on the left side when you look at the equation and the atoms in the periodic table, and one copper atom on the right. But there are two oxygen atoms on the left side, since it takes two oxygen atoms to make one diatomic oxygen, while one is also on the right. So in order to balance this, we will need to add a 2 in the front of the second part of the equation to match the first part. So this would look like Cu plus O2 equals 2CuO. But we are not finished because now the number of copper atoms is not balanced. So we will add another 2 in front of the first part, ending in the final equation being 2Cu plus O2 equals 2CuO. So this would be our balanced equation for copper oxide. So once we have addressed the reaction we are beginning with, we need to address the reactants and their chemical equations before we put them together. So this solution is extremely acidic because we know vinegar has a very high pH, which we have learned in class. The table salt, sodium chloride, which is symbol as NaCl, and vinegar, which is CH3COOH plus positive H2O, will create a weak solution of hydrochloric acid, which is H positive plus Cl negative. This superscript is showing the charge on the ion, hydrogen being positive and chlorine being negative. Before we balance this equation, CH3COOH positive plus H2O plus NaCl plus CuO equals CH3COO negative plus CH positive plus OH negative plus Na positive plus Cl negative plus Cu positive 2, which is very long, Let's place the pennies into the solution so we witness what is occurring physically before chemically. So before we begin this reaction, I would like to show you what the copper oxide looks up close on the pennies. As you can see, as I described, there is a greenish film on top along with a dull looking penny. So our goal is to show the reaction that I have described with the chemical equations of what it will look like after it has reacted with the sodium chloride, NaCl, and vinegar. So first we're going to take 1/4 cup of vinegar and we are going to place it into our bowl that doesn't have any metals on it that could slightly react with the Cu in another way. And then we are going to take the sodium chloride, NaCl, and we are going to take about roughly 1 teaspoon of this and place it, it's a little bit more than a teaspoon, and then we're going to put it into the vinegar. I'm going to leave a little bit out, and then we are going to mix that around until it dissolves almost fully, as much as we can, into the solution. If it isn't dissolving fully, we have learned to place more volume of the vinegar in so that the salt is able to dissolve fully according to the volume. But it looks like we have done our calculations correctly and this is completely dissolved. All right. So after we have dissolved this, I'm going to be placing the pennies into the bowl of the vinegar solution. So here we're going to place them in, and we are going to leave one outside so that we can see the difference in the reaction. So as you can see, our experiment has concluded after I have left them in for 15 minutes, and you can tell already that the NaCl and the vinegar have completely, almost completely, not fully, pulled off the copper oxide that has been oxidized on, and it is showing you that this is happening because it is due to an acidic solution that has sped up the process. And this is our old penny over here that was not put in the solution. So before we can conclude this copper oxidization and chemical reaction equations experiment, we're going to come up with the final chemical balanced equation. So after making sure that all of the atoms are the same for all of the elements on each side, which I had given earlier in the video, the unbalanced equation, now I will give you the final equation that is balanced, showing the reaction that has occurred chemically on the copper oxide. So that would be 3CH3COOH plus H2O plus NaCl plus CuO equals 3CH3COO negative plus CH positive plus 2OH negative plus Na positive plus Cl negative plus Cu positive 2. This shining of the pennies is due to an acidic solution speeding up the process. Overall, this experiment should be a direct example of what happens during a chemical reaction and how to balance that, which we all have learned throughout the course of Chemistry 100. Thank you.